Okay, let's look at homework 8, problem number 4. Right, so we want to use a cylindrical coordinates to write a triple integral to find the volume inside the cylinder. So it looks like it's centered at the origin and the radius is 2. Right, and between, so this is elliptic paraboloid and xy plane, so that's pretty simple. Right, so let's try to set it up, but see, we should probably draw a picture of that. Right, so first thing we should do is let's see, try to draw x-axis. Right, and the y-axis. Right, and the z-axis going straight down. Alright, so those are the axes. Oh, actually, no, I want z there. Alright, z. Right, this is the origin. Alright, so so you have let's say a paraboloid. So let's try to sketch a paraboloid. Alright, then that three-dimensional is too hard, so I'm gonna cut it, slice it using, for example, let's do it YZ plane. YZ plane. Right, but remember that the YZ plane, the equation is quite simple. It's just x equals 0. Right, so if you do that, you're going to get an equation. Just plug in x equals 0. You get that z is equal to y squared. Right, so this is just a parabola in y. So we can sketch the parabola in y. So it's going to look kind of like this. Right, so you have a parabola on the YZ plane. Alright, and we can slice it using XZ plane if we want. So let's do a XZ plane. Right, which means that equation is y equals 0. Right, which gives us, so put 0 there. So z is equal to 2x squared. Right, so on the xz plane, it's a still parabola, a little steeper because of that 2. So maybe I'll just draw a picture right here. So it's gonna look kind of like this. And on the xz plane, and so it looks like that. Alright. Alright, then this has to be inside the cylinder with radius 2. So it's gonna look like this. So so I'm gonna put 2 here. So that's say 2, and 2 here, and that's gonna be -2 there. Right, and that's right here is -2 there. Right, so you have a cylinder. So it's gonna look kind of like this. Right, so it has to be above that, so you can see that it's gonna go up here, and it's gonna probably go a little bit higher here. Oops. And it's gonna go up there, and that's gonna go up higher there. So I think it's gonna look kind of like this. Right, so you have solid, which looks like that. It doesn't look all that great, but I'll do my best. So here I'm gonna just shade it. So here, so this is gonna be a cylinder right there. Right, then since this is an elliptic paraboloid, I don't think it's gonna be straight there, so it's gonna look kind of curved, but I'll do my best to shade it. and you can't really see there. So right, so anyway, so this is the solid, right? So what we need to do is we want to write the triple integral, right, using the cylindrical coordinates. So the volume V is going to be equal to, right, so you have a triple integral, right? Then area, the volume element for cylindrical coordinate would be r, dr, d theta, dz, right? But we can do it in any order. I would like to do it in, we want to do it dz first, then dr, d theta. It's probably the easiest that way. So I'm going to just to change the order here. Right, so we have, I'm gonna do with respect to z first, then dr, and the d theta. All right, so let's do this. We're gonna fix theta and r, right? So if you fix theta, so theta is gonna be this angle right here, right? And r is gonna be there. So those are fixed. Then you can see that z value starts from 0. So this is z equal to 0 because it's going to start from xy plane. Then go up to wherever it hits the elliptic paraboloid, right? So that has an equation, z equals 2x squared plus y squared, right? So, but we have to rewrite it in, we cannot use x and y because we have to use r and theta. So we have to rewrite that. So z is equal to, right, 2x squared plus y squared, right, is equivalent to 2, right, x is r cosine theta. So it's going to be r squared cosine squared of theta plus y squared would be r squared sine squared of theta, right? So this is going to be equal to, so borrow one of the r squared cosine squared, we can get r squared cosine squared of theta plus r squared, another cosine squared of theta, plus r squared sine squared of theta. We can combine these two guys as r squared cosine squared plus sine squared, which is 1. So this is just going to be r squared, right? So we will get this is just going to be r squared, right? We can combine these, let's see, cosine squared theta plus 1, right? So that's z. So z is going to go from, right, xy plane, which is 0, to z is equal to r squared cosine squared of theta plus 1. All right. Then once you've done that, we can just do, go from 0. R goes from 0, so r equals 0, all the way to the edge of the cylinder. So that will cover this region right here. So r is 0, and go all the way up to r equals 2 to cover this cross section. So we can go from r goes from 0 to 2, right? And once you've done that, you can rotate this guy. So theta can go from 0 all the way to 2 pi to cover the entire solid. So theta is going to go from 0 to 2 pi, right? Then you can evaluate this integral on your own. So I'm gonna just say ... I let you do the rest. All right, that's it. I hope that this was clear.